two related experiments, we compared various navigation techniques for working with off-screen content. In the first study, we compared three pure techniques. The first was zooming. We implemented a two-level zoom. With one click, the view zooms in, providing the user with detailed information. A second click zooms out, returning to the overview. The viewfinder is controlled with the stylus. DragMag is the second technique. An inset window provides a close-up view of the area indicated by the viewfinder in the overview. The viewfinder is moved by dragging it, which changes the detail view. The scale of the inset window can be adjusted by using the scroll bar. Fine control is achieved by dragging within the detailed view. The third technique is hop. It is a proxy-based technique where the user drags a laser beam to intersect halos representing off-screen objects. This causes proxies to appear. Clicking on the proxies translates the view to show the selected object. The second study compared the three pure techniques to two new hybrid ones. WinHop is a portal and proxy-based technique derived from hop. Users invoke proxies in the same way as hop, but instead of shifting the main view to the target, a portal appears to show the target without losing the original context. The portal allows free panning and zooming to further inspect the context of the target. Users can then update the main view by clicking the target within the portal. Multiscale zoom is a modified version of zoom that incorporates features from proxy-based techniques. Objects are shown at the same level of detail, regardless of the scale factor, which maximizes their utility at low zoom levels. All techniques were tested with 6 tasks. 3 of them are classified as spatially absolute, which means the user must form a relationship between the object and the workspace. The first task is existence. The user is instructed to determine whether or not the target exists within the map. In this case, the target is a 4-star hotel. Once this has been ascertained, one of 2 buttons on the tablet is pressed to signify a yes or no response. The location task divides the map into 9 regions with a 3x3 grid. A target is randomly placed in one of the 8 outer regions, and the user's goal is to locate it as quickly as possible. Once it has been found, a button on the tablet is pressed, which allows the user to enter a response. As the name implies, the object count task involves finding the number of objects of a certain type, in this case, 4-star hotels. To finish, the user presses a button on the tablet. The user can then enter their tally. With proxy-based techniques like WinHop, users rely on proxy details for doing these tasks. The second category of tasks is the spatially relative tasks, which involve identifying a relationship between objects. The first of these is the proximity between objects task. Users are instructed to find the closest 4-star hotel to a metro station. There are a number of targets of each type on the map. Clicking on the hotel chosen by the user will end the trial. Proximity from reference is a similar task that involves finding the closest object of a given type to a fixed reference point placed at the center of the map. This task is completed in the same way, by clicking the chosen target. The final task is cluster. The goal of this task is to find a tight group of targets exactly matching those shown to the user. Several distractor clusters that do not match are scattered throughout the map. Clicking the metro at the center of a cluster will end the task. We categorize our results in terms of spatially absolute or spatially relative tasks and pure or hybrid techniques. Proxy-based techniques such as hop are better on spatially absolute tasks, but a time multiplexing technique such as zoom provides better performance on spatially relative tasks. We observe that when we combine complementary features of hop, zoom, and DragMag to create multi-scale zoom and WinHop, users perform better across both groups of tasks. Overall, our results suggest that integrating features of different techniques can enhance performance across a wide range of tasks.